The modern supercar world is defined by a central engineering conflict, the pursuit of ultimate power against the suffocating constraints of emissions and efficiency. Where forced induction delivers brute force, the naturally aspirated V12 offers mechanical purity, a highly demanding choice that stakes everything on internal precision. This design philosophy forces an immediate, unparalleled rigor in manufacturing. Now let's open the factory blueprints and deconstruct the story of this engineering titan. To understand the 812 Superfast V12 is to accept a thermodynamic paradox. This engine operates at a red line approaching 9,000 RPM, delivering over 800 metric horsepower without the artificial compression cushion of a turbocharger. Every power stroke relies purely on atmospheric pressure and the flawless synchronization of 48 individual valves. When we analyze the required manufacturing tolerances for a system under such extreme cyclic stress, we are talking about microns, a precision finer than the resolution of the human eye. The components themselves, the plasma-coated cylinder walls, the piston skirts, the crankshaft journals, must align and articulate perfectly under forces that are measured in multiple tons. Any variance, however small, will inevitably introduce thermal instability, frictional loss, or catastrophic mechanical failure within moments of high-load operation. The engineering challenge is thus twofold. First, to design components that can survive this environment, and second, to guarantee that every production unit meets this zero defect threshold. The cost of retaining the naturally aspirated identity is this requirement for mechanical perfection. This necessitates moving far beyond traditional quality assurance. The engine room at Maranello transforms into a specialized laboratory where the manufacturing process is designed not only to build the engine, but to forensically certify its core integrity. The solution to the V12's precision paradox is codified in a mandated 20-step certification protocol. This is not simply a quality check, it is a forensic interrogation of every mechanical assembly designed to validate integrity before the stress of internal combustion is ever applied. The process begins not with assembly, but with advanced component validation before the block is even mated to the crankshaft. High-speed optical metrology systems are deployed. We see sophisticated laser scanners checking geometric tolerances to within single-digit micron, specifically the straightness of the bearing saddles and the alignment of the deck surfaces. This is critical for controlling harmonic vibration and torsional stability at the extreme upper reaches of the RPM band. Once fully assembled, the engine is wheeled into the testing matrix. The most critical step is the non-destructive, cold test. This technique is foundational to premium engine manufacturing as it allows engineers to measure performance without the confounding thermal and pressure noise of actual combustion. Instead of firing the engine with fuel, a specialized electric motor is connected to the flywheel. This external power source cycles the V12 through its entire operating range, from simulated idle speeds up to 5,000 RPM. The environment remains pristine, allowing for the isolation of purely mechanical and fluid dynamic data. In this chamber, an intricate network of sensors takes over. We track instantaneous pressure readings in every cylinder during the compression stroke to ensure perfect volumetric efficiency across all 12 pistons. Piezoelectric sensors measure the minute deflections of the block and the torsional rigidity of the crankshaft under load, looking for structural weakness or imbalance that would manifest as vibration at redline. Furthermore, the data acquisition systems meticulously monitor the engine's internal friction, signature, the exact amount of energy required to simply turn the mechanism. A deviation of just 0.5 Newton meters in resistance can be sufficient to trigger a failure state. The 20-step process systematically eliminates every variable. The engine is oil primed and run through a sequence of thermal conditioning cycles, not from internal combustion, but from precisely controlled external heaters to simulate operating temperature and measure the expansion rates of different alloys under stress. This rigorous analysis provides a complete, non-invasive picture of the engine's mechanical health and longevity. Patent evidence shows this automated diagnostic sweep captures over 4,000 unique data points in a cycle lasting less than 20 minutes. An engine must pass every single one of these criteria. There is zero tolerance for borderline results. If the data signature deviates from the pre-certified golden standard model by more than the established 3 sigma margin, the engine is flagged, disassembled, and its constituent parts are analyzed for immediate scrapping. The V12 is thus certified for its maximum performance potential before it ever consumes a single drop of fuel. The true value of the 20-step certification is not simply the avoidance of failure, but the guarantee of performance consistency. By eliminating mechanical variance in the cold test, the engineers ensure that every V12 is starting from an identical, high-fidelity baseline. The inevitable first fire-up is, therefore, not a test of survival, but a final confirmation of maximum output. When the certified V12 finally hits the dynamometer for homologation, its thermal map and power curve are already predicted with such high confidence that the physical testing becomes a formality. This rigor directly translates into the driver's experience. The high-precision assembly guarantees the longevity required for a 9,000 RPM engine block, preserving the integrity of the alloy under repeated high-load cycles. But critically, it also locks in the car's most defining feature, its unmistakable sonic signature. When we analyze the exhaust note of the 812 Superfast, we are listening to the sound of perfect mechanical harmony, guaranteed by the micron-level alignment of its pistons and valves. The consistency across all 12 cylinders is what prevents destructive, low-frequency harmonic resonance and permits the clean, piercing crescendo that is the hallmark of the naturally aspirated Ferrari V12. This extreme level of certification protects Ferrari's market niche, proving that absolute performance can still be achieved without compromising mechanical purity or long-term reliability. The V12 Engine Room is fundamentally the guardian of the brand's engineering legacy in an increasingly hybridized world. It is here, on the immaculate factory floor, that the intangible element of design ambition meets the undeniable reality of data acquisition. We leave the roar of the final dyno run, reflecting on the immense human ingenuity required to create a machine so demanding of its own existence. The V12 is more than a power unit. It is a meticulously certified object of engineering art, a testament to the pursuit of mechanical perfection within impossible constraints.